Welcome to episode 4 of the Cloud Native Podcast. Today we talk about Cloud Native Fight Club Part 2, Docker vs. LXD, Rocket, Garden, and others. Welcome, everyone, to the Cloud Native Podcast. Thanks for joining us. I'm one of your hosts, Matt Farina. I work at Hewlett Packard Enterprise. And with me today is Matt Butcher from Deis. Say hi, Matt.
Hey.
So the format for the show is we talk about something from what we call the Cloud Native Developers Toolbox, and it's a developer tool and something like that. And then we jump into our main topic, which today is our second in our series on Cloud Native Fight Club, where we look at the technologies underlying what we're talking about as Cloud Native. And so for the Cloud Native Developers Toolbox, today we have something new called Slate. Matt, can you talk a little bit about that? Before you brought it up today, I had no idea what it is, haven't looked at the page. So this is kind of your deal. What do you got for us?
Yeah, so I like to keep my windows organized on my desktop. And when I was a Linux user, I was a big fan of the Awesome Window Manager, Awesome WM, because there's a tiling window manager, so I could take advantage of my screen real estate to the maximum effect. Now, these days I work mostly on Mac OS, and a friend of mine, Adam Reese, pointed me recently to a project that offers a lot of those core features I liked about Awesome WM for OS 10, but with an interesting little twist. So Slate is a tool that manages the tiling of your windows. And you can set up your own custom key bindings and so on to quickly organize and tile and untile your windows. But a recent fork of it also adds JavaScript support. So instead of configuring everything in a declarative sort of way where you say, I want this desktop to look like that, or I want these windows to take up 50% of the left and these 50% of the right, or something like that, you can write scripts that are sort of responsive. So when you plug in one monitor, it can organize your two different monitors together to be presented in the way you like them. And then when you unplug that monitor again, it'll trigger another event and your script can kick off and reorganize things to your liking there. And within about an hour of downloading this, I was completely sucked in, having a great time writing some JavaScripts to do things, that kind of made sense to me, that made my environment work the way I wanted, so that I could, automatically set it up so that when I hit a particular key sequence, it maximized my main window and turned all the others to 500 pixels by 1,000 pixels or something like that. So that one's been a fun one. I'm enjoying that one a lot. And because I feel like it's a good productivity tool for making your developer tools work for you, that's why I thought it was a good fit for this week's Cloud Native Developers Toolbox.
Sounds good. And you can find this over at github.com/mattr-/slate. There's actually a dash in there, which I thought was funny. Or you can head over to the show notes and find the link if you weren't able to pick that up from us talking. So thanks, Matt. Yeah, this was interesting when I heard you talking about it. And the way I heard you talk about configuring your environment, it almost reminded me as another form of authentication. The way you're mapping keys and changing stuff around with this makes me wonder, hey, can another person actually sit down and use your computer and know what the heck is going on anymore? I just found that to be amusing. All right. Yep. So this is part 2 of our Cloud Native Fight Club series. Today we're talking about Docker versus LXD, Rocket, Garden, and there's a whole bunch of them out there. And we're just going to talk through a handful of them, like what the heck's going on. And in the last episode...
We should remind them what we talked about on the last episode to kick that off, right?
Yeah, it's a good place to start. Go ahead.
Because on the last episode, awkward silent moment, on the last episode, we kind of dove into the core container technology. And we talked about what it meant to run things in containers and different ways people have containerized things versus virtualizing them with Zen and various virtual machine layers. And so building on that, this week we wanted to sort of change tacks and look at the competition as it's arisen inside of the container management space.
Yeah. And so last week we talked a little bit about LXC, RunC, and these other underlying technologies that take a collection of of things you can do in Linux. And we said, the winner was kind of that collection of things you can do in Linux that we've loosely coupled into this abstract term called containers. And if you're talking about zones or VMs, that's kind of a first-class object in those other systems. But what really seems to be bubbling up in the cloud native space is this abstract concept called a container that takes advantage of things like namespaces in Linux and stuff like that. And we said, that has kind of won in this cloud native space. And we even at the end declared that Docker won as a certain amount. And we said, hey, Docker is kind of that thing that won. And so that kind of leads me into this first question is, well, what is Docker anyway? And if you followed it a little bit, it can kind of be nebulous. Is it a company? Is it a collection of different things? Is it managing those containers that we talked a little bit about? Docker can be different things to different people, especially if you're somebody who looks at SKUs from companies and different products. You may have even noticed they've had different ones and they've changed over time. So what is it?
Yeah, and we talked last week about how one of the things that Docker, the company, did so well was they focused on the user experience of the tool. They made, compared to something like LXC, using Docker is much, much easier. And I feel like they have parlayed that success not just in their Docker command, but across their sort of product line. And that's been good because, as you can tell, we have to keep clarifying even as we talk about Docker, whether we're talking about Docker Inc. or Docker a product or Docker a suite of tools or whatever, because I feel like they've bubbled up that sort of signature user experience, right? Focus on providing the developer with all the tools they need and associate all of that with the name Docker. And they've almost overdone it to the point where it kind of gets confusing when I say Docker, which of the myriad of Docker's technologies I'm referring to. How are we now? How many Docker products are called Docker or Docker something at this point?
I'm not even sure anymore. And it changes. So just a matter of weeks ago, they changed their versioning scheme and they changed up the way that they distribute Docker to Community and Enterprise Edition. And I still haven't totally mapped how some of the previous things like Docker Data Center fit into Enterprise Edition versus not, and what fits where, because they're all Docker at the same time. And so maybe the basic thing is to say there's a company, Docker Inc., that is VC funded, that is at the heart of it all. And so one of the things that we talk about a lot with Docker is this company that's really at the center of the conversation because they changed the way we distribute applications and those kinds of things that really remade a lot of the market. And then on top of that, there's this thing that originally came out. It was called Docker, and the company actually renamed itself after the thing that was really popular. It wasn't always called Docker Inc. And that thing called Docker was originally a container manager as a daemon that ran on a system, and it would operate initially as far as go and I'll orchestrate and manage all the containers running, and then it added things like the images and stuff like that. But at a very low level, it lets you just manage and run containers really well. And that particular piece is kind of what won the market.
Yeah, and I think that piece is the one that when we talked last week about comparing Docker to LXC or a Docker to run C or the kind of low-level environments like that, that's what we're talking about, right? We were talking about that version of Docker that, Matt, you and I first ran into, which was a way from the command line to build and run containers.
Yeah, and Docker at that point, right, in its first go-around, it actually used LXC under the hood, and it was a wrapper around it for that great kind of experience that we think won and did so well. Later on, they switched over to using libcontainer. Libcontainer was eventually spun out and became runc, the foundation for runc. And so you can kind of see that living on, but that upper layer. Now, after that, they started adding more products out there, right? Like Docker Compose, Docker Data Center, Docker Swarm, and many of those, they even ended up folding back into their Docker. And then at that point, they took Docker, the original, and turned it into, I think it was called Docker Engine, wasn't it?
Something like that. Yeah, I've lost track of all the names.
And then they started folding in a bunch of those products like Compose into Docker Engine, so it was all right there in one thing. And so instead of separate things, they folded it into one. And so this is why when we say, what is Docker? it depends on the point in time you take a look at the snapshot. And 5, 6 months after this episode is originally released, it'll probably change again as they're figuring this out in that iterative VC kind of way and how they're going to handle it. And then afterwards, afterwards there was this cry out to say Docker got too heavy. We want this. We want that lightweight, boring container system with that great experience back as a separate thing that doesn't have all of the, it doesn't have compose and everything else on top of it. And that's when Container D came into the picture, because they said, we hear what you're saying, and so we're going to take that piece out. We're going to send it out as Container D, and we're going to talk about Container D in a little bit. And then now Docker leverages that, and so Docker is now that higher level abstraction, and yet they run Container D, which is that other abstraction that we think won the market that people love so much. Does that sound about right?
Yeah, and I think we could kind of wrap that up by suggesting that when Docker talks about their community edition version of Docker, what they mean really, and I'm going to speak for them here, is this is what we think is the current set of tools that provides the best experience for working on containerized tools. So it's not necessarily containerized environments. So it's not necessarily the case that it is anymore a single product. It might have a single command line on top that's behind the scenes pulling in lots of different functionalities. But I really feel like Docker has sort of taken the view that it's more like something like Visual Studio or the Xcode suite, where there's a top layer that's wrapped around all these other tools that you don't necessarily need to become an expert in order to use them well. And then lower level tools like Containerd or Run-C still exist somewhere in that code base, but they're not the kinds of things that Docker expects their typical user to have to master. And I think a good example of this is Docker for Mac, because Docker for Mac is not just the Docker client. It's actually a very sophisticated product that includes Xhive, which is a virtual machine layer. It includes a tiny Linux distribution that runs inside of a virtual machine that then runs the Docker daemon half, and then it installs the Docker client half locally in your host macOS environment. So it's actually a pretty sophisticated beast that is not at all, directly parallel to something like we looked at last week, like LXC, which is just a simple tool. Does that sound like? I mean, what do you think, Matt, about that particular characterization? Do you think I've taken it too far?
I'm actually thinking about it, and for the first time, I'm thinking, what I see in Docker is that we used to have LXC. If you go back to the beginning, and Docker made that experience great. And I think instead of trying to think of Docker as an implementation of something, it is trying to figure out how do you make that developer experience great. And as we get into, part 3 of the Cloud Native Fight Club next week, when we take it up another layer and we talk about Kubernetes, Mesos, Docker, and all this next level up abstraction, that'll definitely have to be one of the things that we talk about is what is the developer or app operator experience. And I think Docker has been focusing on that, and the bits underneath have changed and their interface has changed, but they've maybe had that core focus the whole time.
Yeah, and I feel like that's a really admirable thing. Docker has clearly played to their strengths. They have worked hard to find the tools that we as developers or as users enjoy using, and they put them together in a way that seems to make sense. On the flip side, I think oftentimes you will hear people complain that Docker, every time a new Docker release comes out, it is, quote unquote, not stable or not production ready. And I feel like sometimes that is because of bugs in Docker, but oftentimes it's because the particular set of tools has changed, and those tools don't always function the way that users would expect them to.
Yeah, they kind of do take the whole move fast and break things as a startup to heart. And those of us those who deal with enterprise or having to operate stable products might say, but we need a little less change. We need it to be, we need a little bit more stability so that way we can operate our stuff on top of it. And so I think that may be where, and the API is changing and building tools to work with it to do with the operations, may be where some of that comes in. But that leads into Containerd, which we're going to talk about in a little bit.
Yeah.
So let's talk about some of these, because we've got and maybe we'll take it to Docker versus, we got a bunch of different things here. And we're really going to break down what are the alternatives for container, runtime management, not the actual container at the lower, but more like what's that daemon that oversees your containers running that provides that experience. And I think at the beginning, we're going to start by talking about the losers. We've already we've already said Docker and their philosophy have won the mind share at heart. So it's worth talking about some of these others to say, well, what else is out there? What's going on with it? And if you're not into Docker and you want to look at something else, maybe these do present, because even though we say they may not have won the mind share, they are developed, they are in use. Some people swear by them, and they're probably behind products that you use today.
I do think that we could start one quick step earlier and say, so what are kind of the core pieces that we talk about when we're talking about a container runtime?
Sure.
What are the things we expect it to do? So, and I think we could say, well, first of all, the most straightforward answer is, well, we expect something that can take something in some sort of image format, right? A source image, and execute it in the runtime. So that seems like, step one for what we're talking about. But that's also sort of broaching the stuff we talked about last week. That's not really managing, that's just kind of running. So we could also say, well, what about all those other things that come with lifecycle management? So there's running it, but there's also interacting with it and controlling it. And then there's building images, right? How do I tell it, here's the stuff I want to be included in my image, build me up an image with just this stuff in it and treat it this way. So I think that's another crucial ingredient. And then maybe one of the optional ingredients might be something like, how do we manage our images once we've created them? Right? Is there a repository? Is there a place to store them? How do I say I want to use somebody else's image to do this, but I want to use my image to do that? Right? So you have, I feel like those are kind of the key components that distinguish a container manager like we're talking about today from merely a simple runtime. What do you think about that, Matt?
I think that's a good way to break it down, so that way we can be on the same page, because I had some ideas and I was not thinking exactly as what you had, but I hadn't thought it is through on a couple of the points. And so I think it's good to level set on which part of the stack we're talking about and the responsibility there. So I like that.
Good. Anything else that you think I missed there as far as things like volume or network management or configuration? I don't know.
Maybe low-level configuration, but not how do things talk to each other. That kind of gets into the next layer we're going to talk about in the next episode.
Yeah, good point.
So, okay. Then with that, should we dive into the very first one?
Let's do. We're going to talk about LXD first.
LXD. So, did you want to take this one, Matt?
Go ahead.
Oh, LXD. So LXD, I think it originally came out of, the folks at Ubuntu?
I believe so, yeah.
Yeah, and it basically is, so last week we talked about, in the last episode I should say, we talked about LXC, which is that runtime that Docker originally used, that I think you'd find was originally used in Heroku and some other places, was that runtime that you could use to run containers. And now if you had to level up to say, what is the container manager for that? Later along came LXD, which is the daemon that could do that management. And it came out of the same folks and is tied to them, as far as I understand. I can honestly say I haven't used it. And so I only know what I've read.
Yeah, actually the same here. Early on, I had experience using LXC because there weren't a whole lot of options several years ago. But LXD sort of matured alongside Docker and some of these other technologies. And while I know a few people who are fans of it, it's not a system that I've ever used too much. As I understand it, I mean, its big differentiation point is LXC is a command that you would run on the command line that would manage the runtime for a particular container. And LXD, the D stands for daemon, the Unix parlance for a server. And it is a server environment that your LXD command line clients can talk to in order to control the execution of an image somewhere on your Linux box.
Yeah. And so is that about the extent of our knowledge on it? It's just, well, I'm not going to speak to the good or bad. It's just not in as wide use. And that's why when I say it's not as one, as we get to some of these others, you'll see they're just more widely used as far as I know of. Now, I know things that used to use LXC, like Cloud Foundry. is an example that used to use LXC. In fact, the first Cloud Foundry distros I think you and I worked with
Mhm.
years
Yep.
ago now. Well, we didn't notice it. It was LXC under the hood, if I remember right.
Hmm. Yep.
And just like many other things moving on, so did Cloud Foundry. And so that's actually the next one in our list is something called Garden.
So just so I'm clear on this, when we evaluated LXD as essentially a quote unquote loser when compared to Docker, and to be really clear, our number one criterion was whether you and I liked it and used it, right?
Yeah, yeah. It's not it's not to speak to some matter of software quality or usefulness, because I know people who use it and swear by it, and it's been, I've used it in the past, and my when I call it a loser, it was more because in the battle of popularity, and mind share, it's behind the next three we're going to talk about, and that's why I put it there.
Yeah, and really it comes down to not a the way we're looking at this isn't like you said, an evaluation of software quality or capabilities or anything,
Mhm.
but like so many software technologies we've seen out there, LXD has just kind of failed to grab the imagination of your typical developer who's working in this space.
Yeah,
It's found its niche, and there are people who love it and are finding great applications for it. But it certainly has not risen in the mind of the public developer or whatever you want to call it to the same level that Docker has.
that's right. And so even LXC Cloud Foundry moved on from LXC
Mm-hmm.
in their latest version, and so that's actually the next one on our list. So they've got this thing called Garden that they use. And if you're not into Cloud Foundry language, their old container manager was called Warden. And they rewrote it in Go, and it's now Garden.
So
And
they changed the W to a G.
yes, they
See what
changed
they
the
did
W
there?
and they rewrote it in Go, and you got a G on the front. See what they did there?
Oh yeah. Oh.
Yeah, yeah. And so they rewrote it. But Garden's a little smarter now. Under the hood these days, uh, they're using Run C. And as I understand it, Garden actually provides a pluggable layer where you can have different engines running behind it, while those who've got to work with Garden have kind of a consistent way to interact with it. So now you can swap stuff out. And for Garden, they used to have Garden Linux. I think there's a Garden Windows. I can't remember.
Yep.
And then Garden Linux, for example, then became deprecated, and now they're using Garden Run C. And Garden Run C is, well, Run C, that we talked about last week. That LXC got replaced with libcontainer. Libcontainer got donated to the OCI, and it became the foundation for Run C. And so now Garden is using that. And so it's using that same core technology underneath the hood that Docker is, or Containerd, and those technologies are using. But they've got this indirection layer called Garden that lets them do that. And that's what's running under the hood in Cloud Foundry these days.
Now, would you call Garden a general purpose container management system, or would you call this really a highly specialized thing that people who are working on Cloud Foundry might know and use, but the broader developer population probably would never have any interest in using this?
Um, I would probably say it's the Cloud Foundry population has followed this more, and Cloud Foundry is pretty popular these days. You see Pivotal, HPE, uh, what is it, SUSE, IBM. There are a lot of companies who've got Cloud Foundry distros and customers who are happily using them. And so underneath all of that, you have Garden, but most of it is, it's hidden behind the PaaS. And so the people who build it see it, and nobody else does, because the PaaS magic just makes it work.
Yep. Yep. Layer upon layer of PaaS magic, keeping you arm's distance or farther away from Garden.
Yeah, but Garden is sitting out there, and it's this technology, and it kind of reminds me the way they broke it up to something that Kubernetes has done with an effort that they have going, and I'm forgetting the acronym for it, but it's something that happens in the Kubernetes space to kind of have that indirection. So you could switch out what's doing that management behind the scenes for whatever your reasons end up being. And so I do find that to be an interesting part of this stack that they've got here and that they've been able to do. But otherwise, as somebody who uses Cloud Foundry from time to time, I use it. Otherwise, I don't even realize it's there.
And I do think it is worth pointing out that one of the things that Garden has been working to achieve that many others have often seemed to have just kind of given up on is abstracting away the difference between a runtime over a Linuxy, Unixy operating system and one on a Windows style operating system. They have been focused on Windows as an equally viable top tier platform for quite a while many of the others in this space have basically started with Linux, and a few have worked on branching out more toward Linux. More toward Mac OS.
Yeah, and what's interesting here is so Microsoft and Windows has engaged with Docker to bring
Mm-hmm.
Windows Server containers to reality, and they're there in the latest version of Windows Server. But long before that ever happened, there were folks in the Cloud Foundry community who were trying to figure out how do I make my PaaS packaged container like workload work on Windows, and did it successfully because they were looking even before Microsoft was engaged. How do you do that? And I got to give them credit for that.
Yeah. Yeah, they've taken a more holistic and reasonable approach, particularly when many enterprises are still Windows oriented, even in the days when AWS has made Linux for the cloud feel like the standard, right?
Yeah.
Okay, so we talked here. So the interesting thing is that we keep skirting this Run C issue, right? And we talked about Run C last week, and again, Run C came directly out of the Docker project, sort of as a response, I feel, to the community saying, we really want a low-level runtime that can run these containers. It doesn't have all the trappings of Docker. We don't care if it's an ugly tool. We don't care if it isn't as polished or newspaper article friendly as the Docker toolkit. We just want that kind of access to a low level runtime. And I feel like that's really where RunC came from. I was at DockerCon when they first announced it, and that seemed to be the audience they were targeting. Do you think that's fair there?
I think so. I think so. And so you had this initial container runtime, but what you didn't have was that layer on top, the manager. That's where Docker and others could still step in and be the manager. Um, but what I think was still missing from that was people wanted boring management. And by boring, I mean it doesn't change. So lots of people can build tools on top of it, knowing that it's not going to change, right?
Mm-hmm.
And from that, we got the next tool on our list that, again, as just as Run C came out of Docker, so did this one, Containerd.
Containered.
Containerd. And yeah, I guess you could say it either way because if you look
I've
at
never
it,
heard
it
anyone else
ends in
say
NERD. So you can call it Containerd, which is a daemon for containers, or you can just call it Containerd.
I'm going to get angry phone calls for that one. Oh.
So Matt, can you talk a little bit about Containerd?
Yeah. Yeah, so the Docker community essentially wanted something like Run C to give low level access to run a particular individual container. But as the high level Docker product is an ever evolving suite of tools, again, the community sort of said, well, maybe what we really want is none of the fancy decorative front end stuff. Again, no Xhive, no Compose, no Swarm. We just want a server like runtime. So again, Docker is the traditional Docker command line app that has been sort of the cornerstone core Docker product since early on is a client server model. You have a client that has the porcelain, right? The flags and the options and everything, and you tell the client what you want to run and how you want to run it and where to get the image. But then it loads all of that information up into a server, and that's the Docker daemon. And the Docker daemon then unpacks the image and creates the runtime and manages the C groups and mounts the volumes and does all the heavy lifting. And it can handle this for more than one Docker image running at a time. It can manage many of them in the same runtime. Now, that particular backend part is the one that a lot of organizations were saying, well, we could really use that piece, and we would really like a stable version of that piece so that we can embed it inside of tools like Kubernetes or Mesos or these larger frameworks in which you run applications. And we'll get to talking about that in the next Cloud Native Fight Club. But because that particular piece, that Docker daemon layer, became the foundation for so many applications, and an ever increasing number of those applications were getting deep traction in large organizations like Google and Red Hat with Kubernetes, for example. Because of all of those things, the community started asking Docker, hey, we need a stable runtime daemon-like thing. And we could go build our own, but we don't think that would be sort of the best use of our mental powers when you guys are already the experts. And really that's, I think, where Docker came back and said, yeah, we'll provide Containerd as a standalone product. How's that sound for a happy story?
That does, because it kind of broke out that boring piece of infrastructure that was already there and just made it accessible. Now, most folks aren't going to interact with this on their own. They'll use a higher level tool that has it, such as Docker itself, or any of the other tools that come along to start using it. Containerd, you know what's interesting about it? Where Runc was part of the OCI, that is the Open Container Initiative, Containerd became part of a different organization.
That's right. A little bit of a surprise move, in my opinion.
Yeah. So Kubernetes and a whole bunch of other things are under something called the Cloud Native Computing Foundation. And it's got Kubernetes, gRPC, FluentD, Prometheus.
Linkd.
Yeah, there's a whole bunch of tools that are on this cloud native bit that are higher level tools that are under the Cloud Native Computing Foundation. And Containerd at KubeCon and Cloud Native Con. What's the right name for that? What's the right name for that conference?
Cloud Native Con.
Cloud Native Con, which many have called KubeCon. At the European one, Containerd was announced as being part of the Cloud Native Computing Foundation. And so it's not just a Docker project anymore. It's now become so boring. It's part of a group that's under the Linux Foundation to oversee it by lots of companies that will hopefully continue to make sure that it's that boring piece of infrastructure they all wanted.
And I think it was a really politically savvy move for Docker to contribute this to the CNCF, the Cloud Native Computing Foundation, because that particular organization, while independent, is dominated by largely Google technologies. And I think Docker was wise in putting this in there instead of trying to stake a claim somewhere else and turn this into sort of two superpowers slugging it out. I feel like they said, no, we're committed to cooperating with Google and the other big players in the cloud native world. And we're going to show that by contributing Containerd into an organization that already is a hotbed for development for Google and Red Hat developers, for example.
Yes, but of course, at the Cloud Native Computing Conference, at Cloud Native Con, you wouldn't have one container manager go in. You'd have two join, because why get one when you can get two?
For twice the price.
For twice the price. And so, at the exact same conference, Rocket, the last thing on our list here, we're going to talk about, also landed as a CNCF project.
Yep.
That caught me off guard. In fact, it actually forced me to go ask the question, what's the difference between Containerd and Rocket? Like, how are they so different that both of them should live in the CNCF together, and how do you differentiate the two? And so I think that may be where we go with our last question here, on our last one, which is Rocket.
Yeah, and Rocket is an interesting one because we've talked about how LXD did not capture a huge amount of the developer sort of cognitive space, right? And Garden was a very special purpose tool and likewise didn't capture a lot of attention. Rocket, I feel like, has gotten quite a bit more attention than these others. It came out of CoreOS, who brought us, Tectonic, the Quay image registry, and etcd, and a host of other projects. And CoreOS built Rocket partly. I think they built everything partly out of curiosity, to be honest. It's like, I think we should tinker with this kind of thing. Oh, look, it's a product now. And I think Rocket kind of, in some ways, fell into that category. But really, I think that what they were after was CoreOS developers have a soft spot for systemd. the newer Linux initialization
Yeah.
system. Really, it replaced the sysv init stuff, and it's very sophisticated and allows a deep level of control of the runtime of all the applications that are running inside of your Linux server or workstation or whatnot. And I think that Rocket was an attempt to start with systemd and the principles of systemd and incorporate the power of the containerized runtimes that they were seeing in LXC and also in Docker as they began to develop this. And so Rocket sort of followed a different evolutionary path. It's always been very, very Linux oriented. There's not really, to my mind, there's not really the kind of option that they could support a Windows version unless somebody first ported systemd as it is over to Windows, which I should not discount these days. Windows is doing some amazing stuff, and Bash and Linux native like runtimes. But that's not Rocket's goal. Rocket's goal has been to create a really top class systemd oriented container management and runtime system for Linux.
Yeah, yeah. And so it's a little bit different than something like Containerd and runc, because runc can do Windows and Linux and eventually maybe other systems as well. This is very much Linux based and tied to systemd. Does it run containers in a different way than, say, Containerd and runc do? How is it different apart from it? Like in your experience of using it, interacting, what else is different about it?
I mean, I guess my view of runc is that did it really it starts with the runc kind of assumption that I, as a container operator, am interested in running one container in and managing it with one process. So Rocket will start up that container, and Rocket will run from the time it starts the container to when the container exits, and then Rocket will exit along with it. It's not a daemon process like LXD or container D. I'm trying not to say containered. So it's really more sort of follows the typical Unix client model, where it will execute something, wait for that something to wrap up and return, and then execute there. As far as I know, there's no way to run Rocket as a daemon. Now, I have to admit that I've never actually tried, but I've never noticed it anywhere in the documentation or anything like that. Instead, it's really designed to be a one-off command that you would run to execute a particular container. Now, where Rocket, I think, distinguishes itself from runc is that I feel like they've put a lot more effort into making Rocket the kind of thing that a end user could actually run from the command line, and not necessarily a building block upon which other tools will necessarily be built in order to make it a palatable experience. It's designed to feel kind of like the Docker client, but to run more in this single process model instead of the demonized client server model. How's that
Okay.
sound?
That's a good way, and it kind of makes sense then to have Containerd and Rocket both as part of the CNCF, because each of them, fills in a slightly separate niche where they're both useful and they're both container management related, but they're a little bit different from each other. So you would use them for different use cases. There's different ways to approach them, and so they can actually live side by side with each other in the same foundation. And knowing there's a little bit of overlap, there's a little bit of different use cases and how you would use them, but they can fit there.
Yeah, it's probably also worth noting that the two of them ran their native container format was different. Docker's was the Docker format, and Rocket's was the ACI format, and they both sort of converged roughly on the Docker format, which was released in a sort of public format as the OCI. But Rocket can still run both its old images and, well, it can run all three, a standard OCI, and it typically can run whatever Docker can produce. So in that way, Rocket and Docker have differed at a fairly low level. Even Rocket and runc originally differed at a low level in terms of what they could load and what they could build and that sort of thing.
And I think you brought to a good point there. That brings back around to one of the reasons we keep saying, well, Docker 1, which was a very early on thing, because even Rocket, who came along as a competitor, said, you know what? We're running their container format. We're running their image format because they're the big name in the market. We need to be able to do their files. There's such an elephant in the room that running their files is important, and it might make or break our usage at all.
Yeah. Yeah.
So that catches my attention to come back to it. But I think these days, where I said Docker 1 before, I was originally talking about that low-level engine thing. I think that, we keep moving up the stack, right? We solve a low-level problem, we move up the stack. And so we had running containers. And it looks like that run C is mostly winning that market now. But there are a whole bunch of others out there too. And so winning is in just overall use. And then if you move up the chain now, the next boring bit is kind of container D, which has got a whole lot of this stuff. Even though it's new, it's really that boring core part of Docker. And so the real differentiation, the real experience piece that is where we're competing now is in the next level up the stack, which is where Docker lives, because Docker lives at every layer in the stack. Kubernetes lives, Mesos live, and just these next level up tools that now say, okay, now it's not just about executing and looking over a container, but your application, it's got to scale horizontally. It's got to stay HA. We got to make the experience of interacting with things palatable. Let's move that experience up a level. So now I just don't do my individual container, but now I deal with my application a little bit more abstractly. And I think, is that where we're at, which is really our next episode?
Yep, I think that is where we are. I think that, if we had to strike a verdict about what company won this week, it would be Docker, because both Run C and Container D came out of Docker. But when it comes to the actual technologies underlying them, I think that what we're seeing is several different very viable technologies. And really, it is going to be that next layer that we talk about next week, where we ask the really hard question about when it comes to the way you and I are going to be interacting with these container runtimes from now on into the foreseeable future, or these container management layers from now on to the foreseeable future. How are we going to interact with them? And that set of tools we talk about next week is definitely going to define that category for us.
Yes, and that should be a fun one, with maybe folks being the most passionate or argumentative or in different camps of them all. So that should be fun.
Yeah, it should.
All right. Well, thanks everyone for listening to this episode of the Cloud Native Podcast, and we hope you all come back next time. Have a good week.
Bye.
Bye.